Okay, hi everyone. Right. So this is the sharing sections. I just summarize from the topic that I know on this uh, computer security, just about malware. Um, but this is just a summary. So I would like to use these recording sections just to share with you. So maybe this could help a little bit. So so my method on this is like I go through the slides and then I make use of the AI uh, just to summarize some of the key points. So then I trying to put it here so that maybe I'm thinking this will be helping uh, to get the informations. So, okay, without further delay, just let us go through it. So, this sharing section also will be a bit dry. It's going to be theories. So first of all, it's about the introductions to the malware. So, if you go for the internet, um, ChatGPT or whatever sources, there will be a lot of the definitions. So for here, so malware is referred to the malicious software designed to damage, exploit, or take unauthorized control over the devices or the network. So the main type include like virus, worm, Trojan horse. So virus is required a host file or a program spread through the human actions like sharing infected files. Okay, some of the code has been injected to the existing file and so on. So worm is on the other hand is spread autonomously. It can replicate itself if you are exploiting the vulnerability without the human interventions. So Trojan horse um, masquerade or fake or pretend it spoof okay, as a legitimate software performing malicious actions when it's installed. Okay, so when next come to the vulnerability disclosures, so vulnerability are inevitable in software development and can be detected at any point during the product life cycle. So ideally, vulnerability are prevented through secure design and robust uh, uh, testing. Let me just make it bigger. Vulnerability suppose can be prevented, okay, through the secure design, robust testing, but many are just disclosed after the deployment, after you deploy to the production, after you release to the user to doing it. Uh, so responsible vulnerability disclosures involve informing the vendor about the flaw, the bugs, giving them time to fix it before publicly disclosing it. So sometimes the programmer or the developer or the people who working on the code, they're able to detect it first let uh, before causing a lot more damage to the public, to the end user. All right. Then is the phases of the responsible disclosures. So we have latent flow, discovery, notifications, validations, resolutions, release, follow up. So latent flow, something is like the flow, the bug already exists, but is undetected. Okay. Discovery is like here is mean like it may be discovered accidentally, accidentality, okay, or through the research, and sometimes attacker may already be exploiting it. okay, using some discovering tools, some pen test tool or something. So notification here is mean the vendor is notified of the flaw. The vendor, they know it, they tell you. Validation is mean the vulnerability is verified. Resolution is the issue is fixed, the patches has rolled out. The patches here is meaning that you know there is some bugs, right? So you need to patch it. So you release like sometimes the window update, sometimes it's an application update. If you're using your phone, right, you will receive some update, right? So all these are the so-called patches. Can be the major one, the minor one, whatever. Okay. Release vulnerability detail are made public or shared with the specific group. So vulnerability detail can be shared through all these CVE website, exploit DB. There is a lot of the website will show all these vulnerability detail and make public and share with the specific group. And follow up here means ensure that the fix work and does not introduce the new issues. Okay. Then we have another term. This one may be new. It's called a zero-day vulnerability. So zero-day attack, which means exploit a vulnerability that is unknown to the vendor or developer. So they do not know. Okay, if you are the programmer, you are the developer, or you are the vendor, okay, you do not know the vulnerability, and it happened exploit. It happened exploit. So then this is called a zero-day attack. Okay, since no patch is available, so zero-day exploit are particularly dangerous. Okay, because there is no patches yet. Okay, responsible disclosures. Responsible disclosures is to prevent this attack by allowing time for fix before the vulnerability is widely known. All right, then that is a topic called race conditions. So race condition is a situation where the outcome of a program or the system depend on the timing of event that cannot be precisely controlled, often occurring in concurrent process, like you have multiple threads accessing the same resources. So race conditions have a serious security implications, allowing attacker to cause unintended action such as denial of service (DOS) or privilege escalations. Meaning, some attacker able to get higher level of their access, right, like admin, administrator, root, and so on. So he's able to perform privilege escalations. So DOS basically is like making your application unavailable. So it's like your machine is hang, the website is hang, you cannot use the services available. Okay, that's called the denial of service. So later we will go back more detail in this. Uh, so here, a sample of a race condition can occur when checking file access and then opening the file. So this is a C code, the C programming code. So if access some file, this is another variable w underscore OK equal to 0, ft equal to f open some file, then wp plus. So then you perform something and then you f close the ft. So else you throw some error, error one, error. Okay, so attacker can exploit this by changing the file between the check and its opening. So instead of some file, you change to some other things. So later we will go come back here and see how. Right. So prevention and mitigations of the race conditions. So we control the order of the operations. We ensure critical operations are performed atomic, atomically using some locks. Okay, mutex semaphores. So and then isolations in databases and file system can prevent race conditions. Limiting the number of the concurrent sequence may also help. True, it's not always effective. So my understanding is you just reduce the possibility of having the race. Race, right? Race. Everyone is right racing for the resources. So there is a lot of things you can do to stopping these race conditions. So applying the lock is a very efficient for me. It's like you control. So if the resources is used by the A, so you must wait until A release the resources, then only B can go in, something like this. Okay. Again, next go to the type of the malware. So this one I did not put a lot of things because actually there is a lot of information from the internet. So like viruses, bomb, spyware, adware, trojans, and actually the list is going on. There is a lot more of the type of the malware. So you can go through yourself definitely. So viruses actually is spread with user interactions attached to a host file. Uh, Worm is a self-replicating, do not require human actions or host to spread. Spyware gather user information secretly, including the password and the keystrokes. Adware display unwanted advertisement and may track user behavior. Trojan, discount. I mean, like faking, spoof it. Okay, faking itself as a legitimate software, often serve as a backdoor for the attacker. Okay, so then botnet, a network of the compromised devices are controlled remotely by the attacker. So botnet can be used for distributed denial of service, DDoS attack, spam, and data theft. So actually, there is a lot of the things can be done by the botnet. Basically, it's just like a zombie. We call it zombie because your machine, like for example, is been compromised, but your machine you still can use it, but you do not know actually there is something already maybe injected inside, you don't know, and then it can receive or control by the command CNC control and command center, something like that, by the attacker remotely to issue some command using your machines. Okay, so ransomware, maybe this one you heard a lot a lot uh, about this, like ransom, right? Meaning they just like kidnap your computer. If you want your thing to be released, you have to pay the ransom note, pay the money. Okay, so ransomware is encrypt victim files and demand for the payment, typically like in the Bitcoin and so on to unlock them. So notable example like crypto locker, WannaCry, which cause widespread damage by locking critical data and demanding ransom payment. Okay, next, rootkit. So rootkit is very difficult to detect it. So rootkit hide the presence of the malware, making it difficult to detect and remove. They operate at different level, including user mode, kernel mode, and firmware rootkit. So firmware rootkit are the hardest to remove because they are persist even after reinstalling the operating system. So rootkit, if you asking myself, the challenges is like it's very hard to identify because it's like it go to your system file, DLL, and so on. So sometimes it's increase the challenges to identify them. Yeah. So prevention and the detections. Next, so prevention and detection. So there are a lot of the antivirus software, firewalls, okay, and regular security update to minimize this risk. Okay, antivirus, firewall, you need to perform security updates and so on. So like for example, be vigilant, never open untrusted file and email attachment, limit the administrative privilege. If you do not need the root, you don't use the root. If you do not need the administrative access, you don't use administration access. So object reconciliations method like verifying the file size, checksum, date spam, help detect tampering. One of the thing I love to use is like the virus total. So if you're unsure, then you can throw the file there, so it can help you like to verify some of the informations like file size, the checksum is like MD5 checksum, SHA-1 checksum, SHA-256 checksum, just to verify whether your file has been tampered or not. Okay, so yeah, that's all for this. So okay, it's like the conclusion is like malware attack and the vulnerability are persistent threat. So staying informed and following the best security practices can help mitigate the risk. And regular updates, responsible disclosure, and awareness of the zero-day vulnerabilities are key in minimizing the damage from malware and race conditions. Okay, so next I did try to we need to go back to the race conditions. So this is the code, the snippet. Okay, just a few lines of the code. So following the lines is like I'm trying to issue some prompt, okay, to the chat GPT, and then I trying to make myself to understand more on what is this code trying to explain. So let us go through. So this C code check if a file is writable and then open it for writing. So the potential race condition occur because the check, the access, and the file operation F open are two separate steps, leaving that the window got opportunity for an attacker to exploit a system between them. So this is the step-by-step explanation. So access this some file, okay, then w underscore okay. So this function check if the file, okay, some file exists, whether it is writable. Okay, that is a flag, w underscore okay flag. If the file is writable, the function returns 0, the program print access granted and proceed to open the file. If not, if it triggered an error, like for example here is one errors, okay, which is mentioned in the here lah. Okay, if it can access, it's okay, so it's grant the access, okay, 0, then printer access granted, otherwise print error. So then f open some file wb plus. So this function open the file in read write mode, wb plus, which allow reading and writing to the file and create the file if it doesn't exist. So after opening the file, the program performs some write operation and then close the file using f close. Okay, next. So this explain, okay, potential vulnerability of this race condition. So the problem with this approach is that between the access check and the f open, there is a brief time window whereby the state of some file can change. This is where the race condition can occur. So assume, okay, a sample. So let's assume the file initially writable. The access function returns 0, meaning the program proceeds to open the file for writing. Before the program execute fopen, an attacker could replace some file with a symbolic link or SYM link to a different file, such as a sensitive system file. For example, the slash etc slash passwd, the Linux file that store user credential. So now instead of the writing to the original so-called this file, the program write to a sensitive file, potentially corrupted or overwriting important system file. So in terms of the attack scenario, it's like the program check access some file w underscore k and find that some file is writable. Before the program execute fopen, okay, the attacker removes some file and create a symbolic link pointing to a sensitive system files. Let's say this etc password file. So when open this some file wp plus runs, it does not open some file as expected, but instead open the link sensitive file. So the program write to the file, possibly causing a privilege escalation or denial of service. So with this, I think is explained a little. So why this is dangerous, because the time gap between the access check and then the f open, this function call allow the state of the file to change, can create something call this a TOU, time of check, time of use vulnerability. So the program assumes the file state is unchanged, which can be exploited by the attacker to perform malicious actions. So in order to like prevented this, so this is the suggestion given by the ChatGPT, but again, this is just a sharing session. So just like telling you that there is some of the way to prevent this type of the race conditions. Like for example, here he said use atomic operations. So atomic operation combine the check and the file operation into a single one step. For example, on the Linux, you can always use like open this system call with the appropriate flag. Okay, with this and this like together, create and execute. I take atomically check the file exists and open it, prevented it or being replaced in the interim. Right, for example, this is the code. So you can see the moment when he open the file, he just like this is the syntax. Okay, put it together. Okay, if it's like -1, so open, else perform the file operation here. Okay, so in this case, the file is created only if does not exist. Okay, o underscore create and then pipe o underscore execute, something like this. This ensure that the check and the file creations happen atomic step, leaving no room for an attacker to interfere. And also can use the file descriptors FD. So instead of checking the permissions separately, you can directly operate on file descriptors, which represent an open file. This removes the time gap between checking the file and operating on it. Okay, and then it's also like set the file permissions carefully. So always ensure that sensitive file are secure with proper permission and avoid using temporary file in directory where user can modify them. For example, under the temp or the var temp. So and then the locking mechanisms using a file lock mechanism such as flock or lockf to ensure that only one process can access the file at the time. Locking mechanisms. So with this, the race conditions, like especially in the file access, pose a significant security threat. By using atomic operation carefully, managing permission and employing locking mechanism, you can minimize the risk of such vulnerability. So the key is to avoid gap between critical operations like checking and using a file as this gap opportunity for attacker to intervene. So yep, that's all. So I think this summarize so on this topic. So thank you for watching. So yeah, thank you. So I'm going to stop here.